Okay, so understanding the vector projection for geometric and then relating the equation to it, it's actually pretty simple once you make the connection between a right triangle and the notation. So the idea here is on my iPad here. Okay, the idea is we start with this connection right here. The magnitude of u times the magnitude of v cosine theta is equal to the dot product. This notation, u and v, is just another way of writing the dot product or the product between two matrices, things like that. So start off with that connection. We know that that's true, which if you want to find the angle between two vectors, you would use that equation. So if I then also let me do this. Let me recognize uv is u dot v and vv is v dot v, which is v magnitude of v squared right here, which you should be hopefully somewhat familiar with that. If not, that's okay. That's what we're here for. Okay, so then geometrically, let me look at this. Let me draw this triangle again. This is the first time I'm using the iPad, so the cursor doesn't follow. Okay, so let's say you've got, and there's only 5 minutes to work with. You say you've got these two vectors here. This right here is going to be your projection. So it doesn't matter if the vector starts here or it starts here or way over here or whatever. It's going to cut off at a right angle like that. And so let's call this u and we'll call this v down here. So then this vector here, if you see this red vector over here, this red vector is the projection of u onto v, okay? So go back to your brain and right triangles and remember, what is this distance right here? What is this distance right here equal? The distance of that red vector there. If you think of this in terms of a right triangle, it's the radius u multiplied by cosine the angle theta. So I'm going to take this equation here and rewrite it as the distance from here to here, from the tail to the tip of the red vector here. And so that's u, the magnitude of u, times cosine theta, which is equal to u dot v over the magnitude of v, which you can write as this notation and this notation. That's fine. It means the same thing. So I rewrote the hypotenuse the length of the cosine part, the x-axis, I rewrote that using the hypotenuse multiplied by cosine theta. Then we take the unit vector for v, which is v over the magnitude of v, okay? That's equal to 1. The distance of that's equal to 1. So if you multiply a vector times that's equal, if you multiply a vector with a length of 1 times something, it doesn't change it. So over here, I'm going to slap in a v over the magnitude of v here, which then becomes, let me use your notation, u comma v over v comma v, and then times v. So I multiplied it by 1. I didn't change the equation. That's why I can add that in there. And multiplying it by 1 is, instead of giving me the length of said vector, it's giving me that vector in the direction of itself, okay, of the original vector. So whenever when you take a vector and you divide it by its magnitude, you get the unit vector, which is equal to 1, and that multiplied by another vector or dot product with a vector sends it in the direction, not dot product, but multiplied by a scalar, sends it in the direction of the original vector. So if you see the geometry, you have a right triangle, and we just used these notations to rewrite one length in terms of a classic r cosine theta. It's your hypotenuse multiplied by cosine gives you that. And then we just used the fact that you can multiply it by 1 to get that, which gives us that formula. So they stop us at 5 minutes on these expert video problems. So I'll have to end now. And if you have any questions, let me know. Thanks.